here we go. Let's take a look. We'll do number 3 together. I'll let you try number 4 on your own. Real quick, why did they give us 2 arrows right here? Those are parallel lines, okay? Parallel lines often have 2 different types of angles, and this is huge for proofs too. Which 2 types? AIA, alternate interiors, or CA, corresponding angles, okay? So look at your setup. If this is your transversal, then what angle should you know right now? Angle 3. What is angle 3 going to be? 64. You guys, if I could just plead one thing with you, it is not just to do this. Because while that's great, it doesn't help you see everything you need to see. Write it here. Angle 3 is 64. Because usually that's going to lead you to something else. Okay? Can anyone tell me how to find angle 1? Yeah, this is a linear pair, right? They share a vertex and they form a straight line. So 88 plus the measure of angle 1 should be 180 degrees because a linear pair is always 180. So subtract your 88, and what do you get for angle 1 then? 92. Okay. Again, write it in on the picture. Angle 1 is 92 degrees. Honestly, you guys, the other thing that's helpful is if you write it in on the picture, it's easier for me to see if you saw what you needed to see. You just had the wrong number somewhere, okay? So just write it in every time. How can you find angle 2? What are you going to say, Ryan?
I was going to say you do 180 minus angle 1.
Right. So you have a triangle right here. And a triangle always adds up to 180. So the measure of angle 2 plus the 92 plus the 64, right? Those 3 have to make 180 degrees. So you're just going to subtract that. What is that? 156. So take 156 away, and you get 24 degrees for angle 2. Okay, look for triangles, look for linear pairs, look for vertical angles. Are there vertical angles in this picture? No. There's not, but look for them because there often are. How would you find angle 4? There aren't corresponding angles with angle 4. You could do SSIA, kind of.
Add 64, 81, and subtract that by 180.
Yeah, so these 3, right, make a straight line. They're not technically a linear pair because there's 3 of them, but there are 3 angles there that form a straight line. Anything that forms a straight line adds up to 180. So 64 plus 81 plus the measure of angle 4 should be 180. So you're going to subtract, what is that, 145? So if you take 145 away, then the measure of angle 4 would be 35. Again, write it in. If 4 is 35, then how do you find 5?
35 plus 64 plus 34.
Yeah. So here's a triangle, and that triangle has 35, 64, and 5. That should add up to 180 then. What do you get for that? 81. Do you see alternate interiors there? Here were your parallel lines, right? If this is your transversal, these are alternate interiors. So you could have gone that route too. Okay, questions on that? Yeah, Eli.
So I understood everything else, but how did you get angle 3?
At the very beginning. So let's change colors here. Your parallel lines, okay, I'm going to make them orange here. Right, those are your parallel lines. So if we treat this as a transversal, then this angle and that angle are corresponding angles. If you take everything else away, maybe it's a little easier to see. It's lines like this with a transversal. Those two are the 64s, right? Corresponding angles. Okay, I'm gonna let you try number 4 on your own. I'm gonna do 5 and 6 with you. I just want you to see how 7 and 8 are a little bit different. These ones you're solving for an angle measure. This one you're just solving for x. Okay, so if you solve for x, then how do you find the angle measure? Plug it into that angle, okay? But let's do 5 and 6 together, and then you can try 7 and 8 on your own. Look at how 5 and 6 are different. What would you do on number 5? You have all the interior angles of a triangle. That always equals what? 180. So you're going to go 8x minus 35 plus 6x minus 5 plus 3x minus 1 should equal 180. Okay, so add the 3 together, set it equal to 180. 8x plus 6x plus 3x. Please don't start doing the subtract or do the opposite stuff, right? You want to simplify your like terms first. So this is 17x. And then combine your constants. Negative 35 minus 5, so that's a negative 40, minus 1 is a negative 41, and that equals 180. Okay, now you can start doing the opposite. So we're going to add 41. So 17x equals 221. And then divide by 17. Anyone know what that is? 13. So x equals 13. Questions on that? Okay. Then look at number 6.
Wasn't this one the one where you add those two inside angles to equal the outside?
Yes. So the two interior angles that are not touching the exterior one that you have, these two are going to get added together, and then you'll set it equal to the outside angle by itself, okay? So you're going to go 2x plus 20 plus 5x minus 11 equals 11x minus 63. I promise there is one like this on your test, so make sure you remember when it's an exterior, you're adding the interiors together and setting it equal to the exterior. So this is 7x plus 11 taken away from 20 would be a positive 9 equals 11x minus 63. So take away your 7x. So 4x equals, add your 63, and then divide by 4. That's 72 divided by 4, 18. Any questions on either one of those? So if you know all the interiors, set them equal to 180. If you don't know all the interiors, set the interiors sum equal to the exterior by itself. Okay, moving right along. Take a look at this next batch in its entirety, right? It's isosceles and equilateral. Can anyone tell me what an isosceles triangle is? Two sides that are the same. Technically 2 or more, but the less specific version is 2 sides that are the same. What's equilateral? All sides are the same. Okay, so tell me about the angles in an isosceles triangle. In this one, the bottoms. Is it always the bottom? No, it's always the ones across from your congruent sides, right? So across from this side is this angle. Across from this side is that angle. So those two base angles are congruent, okay? But if you went here, these two being congruent means the sides across from them are the sides that are congruent, right? So it's always the sides across from the congruent angles or the angles across from the congruent sides that have to be the same. Okay, so then how do you find on number 9 the measure of angle R? What is the measure of angle R? 74. They're congruent, so I know this is 74. Again, I would write it in so that you don't forget that you have 2 of your 3 angles. How do you find the third angle Q? 74 plus 74 plus whatever the measure of angle Q is should equal 180. You get yourself a triangle, okay? So we're going to take away 144. And that should be the measure of angle Q. So that's going to be 36 degrees. Questions on that? Okay, so that's isosceles. What if they give you the vertex angle? So here's your congruent sides. Which angles are congruent in this picture, number 10?
E and G.
E and G are the congruent angles because they're across from the congruent sides. So if you just call this X and X, the thing that we're solving for, because we know they're the same, so call them both X, then you can say X plus 106 or 2X plus 106 should equal 180. I'm not going to solve that. You can solve that, but that should be your setup. Simon, what's your question?
Oh, no, I was supposed to do it.
Oh, okay. Look at number 12. How do you find the measure of those angles?
Is that a 60?
They're all 60. If it is equilateral, then 180 cut in 3 equal parts is going to be 60 every time, right? So you will have 60 and 60 and 60 for all 3 of those, okay? So what do you do on 14?
9x minus 3 plus 60 plus 60 plus 60.
So you could set it up 9x minus 3 plus 60 equals 180. What's another maybe simpler way to do it?
You just know it's 6.
You know that angle is 60, so just say 9x minus 3 has to equal 60, okay? The other thing is you could take 9x minus 3 plus 9x minus 3 plus 9x minus 3 and set that equal to what? 180, because you used 3 angles, okay? So there's lots of options there. It's just a matter of which one do you like the best. If we solve this, then you get 9x equals 63, divide by 9, so x would be 7. Okay, number 18. I'm going to do letter A with you, and then you can do B and C on your own. Yes, Scarlett.
If we don't get specific and on the test we forget to write like a degree on, are we getting points off?
I'm usually pretty forgiving on degrees. I would love for them to be there, but
Okay.
yeah. Okay, who wants to do this one for me? One congruency statement. I'm going to give you the first 3 letters. I'm going to say triangle SUT is congruent to. Who can finish that off for me? Which triangle?
R,
SUT is RPQ, right?
Is it gonna look exactly like this on my test, or are we gonna have to put the? Yeah, is like are the shapes gonna look like?
There's not a question that looks just like this. This is more like when you're in the middle of a proof and you have to tell me which 2 triangles are congruent, are you going to be able to do that for me? So it's more in a proof, like you should be able to say this triangle is congruent to that triangle and have the right pieces matching up. Okay, so here's what I did and what you all did. S had 3 arcs, so you need to find the one that has 3 arcs, right? So S went first and R went first. Then 2 arcs to 2 arcs, then 1 arc to 1 arc. Okay, so match them up accordingly, which I will let you do on number 19 and number 20 for that matter. Okay, look at number 21. It says, what methods are there to prove triangles congruent? What? AIA doesn't prove triangles congruent. AIA proves angles congruent. What proves triangles congruent? ASA would be one. Give me another one. SSS. Give me another one. SSA does not, because that's just donkey backwards, right? AAS would work. Which is the same as SAA. So you can do AAS or SAA. They're the same. What else? That's 3. How many are there? HL, that's 4. SAS. Okay. The ones that do not work are donkey, donkey backwards, and AAA doesn't exist either. Okay, so if you ever see those, think, nope, not going to happen. Now, when does donkey work?
It's a right shell.
If it's a right triangle, but then it's HL, right? You'll still never write ASS or SSA. Okay, so let's look at letter A here. Can you prove those two congruent? What? It's not AAS. ASA. Okay, here's the deal. You have an angle, you have a side, you have an angle, you have an angle, you have a side, you have an angle. If you put the letters by it, the side, if it is touching your two angles, then it's the included side, right? So angle, side, angle. If it's not touching both the angles, then it's angle, angle, side. Does that make sense? So if it's between your two angles, then it's ASA. If it's not, AAS. All right, what about letter B? What would you mark on this one for me on your test? The reflexive. This is congruent to itself. So does that prove those two triangles congruent? By SSS. Great. What would you mark on this one? Vertical angles. Does that prove those two triangles are congruent?
Yes.
By what?
No, those.
Which is donkey backwards.
Or would it be?
Is that a right angle?
No. So not.
So we're going to say not enough info. I never told you those letters. Or you can say no, right? This does not prove them congruent. I like NEI because we don't have enough information. They might be congruent, but this is donkey, right? This is ASS. If you see ASS, you have to say, I don't know. They might be, but they don't have to be because of that. Okay? So not enough info is a great answer, or you could say, we can't tell, something along those lines. How about letter D? That is HL. You have a right angle. You have the side across from the right angle, which we call a hypotenuse, and you have a leg congruent to a leg. So this would be HL. Question for you. What would you do for this one? Vertical angles.
The double line or the parallel line.
Okay, so parallel lines get you alternate interior angles, right? So you could either say this. If you said that, what is this? ASA. Okay, what if instead you said these two? What is that? That's angle, angle, side, because now it's angle, angle, and a non-included side. Notice this side does not touch that angle, so it's not the included angle. This would be AAS, but if it was the other setup, then it would be ASA. So just pay attention. Do you have the included side? Do you have the included angle, depending on what your problem is working you through? Okay? Okay. Let's do 27. It's the most steps, and you don't have your left side. They say BC is parallel to AD, so mark that. BC parallel to AD, and then angle BAD. If it's BAD, what is your vertex? BAD. A. It's always the middle letter. So BAD is right here. DCB is right here. Okay, so those are your givens. I'm not even going to write those in right now. We're just going to say given. Okay, but we marked what we know. The last thing you're going to prove is AB congruent to CD. Any guesses what the reason for that is going to be? CPCTC feels highly likely, right? Which means if that's the case, then the step right before it is to prove the triangle's congruent by SSS, SAS, one of those. Most likely. Not necessarily, but most likely. Let's see if it works out that way. Why are they telling us that these lines are parallel?
That means that, D will have the double mark.
What will have the double mark?
No, I don't know.
If these are your parallel lines and this is your transversal, what type of angles did we just create?
Oh.
What are these called? Alternate interiors. So we would say angle ADB is congruent to angle DBC because of alternate interior angles. What else do you know in that picture? What parts do you know have to be congruent, Simon?
Can't ABD be congruent to BBC because the line.
But you're naming angles. Are you saying this line?
Yeah.
That's segment, right? So you would say segment, that's the right move. BD is congruent to BD, right? That's oops, not BC, BD. Why is that? Reflexive. Okay, now look, can we in fact prove triangle congruent to triangle?
Yeah.
By what? AAS, angle, angle, non-included side, AAS. So you just have to make sure you name it appropriately. If I say ADB, I went 1 arc, 2 arcs, no arc. So I need to go 1 arc, 2 arcs, no arc on my second one. So that would be what? CBD by AAS. So then why are those two segments congruent? CPCTC.
Miss Spring,
Yes.
when we get marked down, if you like mix up the like letters for CPCTC.
Maybe a half a point. Just think every other letter is a C and everybody wants playing time. Or maybe you're needing physical therapy because you got injured. PT. PT in the middle.
Would it be okay to say triangle ADB is congruent to triangle DBC without the line?
No. You have to make sure you're matching up the corresponding parts. Right? So if I go single arc, double arc, no arc, then on the other one, I have to go single arc, double arc, no arc.
Got it.
Okay? Okay, pick one. Which one do you want to do? 23 through 28. 23. You always want the left side, huh? Okay, so first step is your given. Last step is triangles congruent. What does that mean about your last reason?
It's gonna be
SSS, SAS, ASA, AAS, HL, right? Triangles congruent is going to get you that. Okay, so step one is given. Can't really mark anything for that given, but it says Q is the midpoint of PT. So here's PT. Q is the midpoint. What does that lead you to? PQ congruent to QT. And what's the reason for that? Not reflexive. Definition of a midpoint. Right? If you see that midpoint here, you're going to see it elsewhere. What else can you say?
RQ is congruent to QS.
Why is RQ congruent to QS? Also definition of a midpoint. So you really have to pay attention to your given because your given says it's a midpoint of two different things. So that's getting you two different pieces of information. Okay? All right, what else can you say? Look at your picture. What do you know to be true in that picture? Vertical angles. Okay, now this is where I see a lot of mistakes. How do you name those two angles?
QR and QS.
Not QR and QS.
RQR.
PQR. Okay, so PQR, that's this guy, right? The middle letter has to be your vertex. So it's Q, but PQR is here, okay? That is congruent to what? TQS, or you could say SQT as long as Q is in the middle. That's vertical angles. Okay, so then why are your triangles congruent? SAS, a side congruent to a side, the included angle, and a side congruent to a side. So SAS. You want to start one more? Or you want to finish the rest on your own? 24, 25, 26, 28. 24. All right, notice it says bisects an angle, right? So that leads you to congruent angles. So step one is your given. Then it says BAC, that's this angle. Congruent to DAC, that's that angle. How do I know those two angles are congruent? That is the definition of a bisector. If you want to say angle bisector, that's fine. Then it says BCA. That's this angle, BCA, congruent to DCA. That's that angle. Also definition of a bisector. All right, if it bisects both angles, AC congruent to AC, you mark it. That's reflexive. So then how are those two congruent? Angle, side, angle. ASA. Okay. All right.